In 1905, horses still mingled with cars in the street. Ty Cobb was a major league rookie, and Albert Einstein was a low-ranking clerk in the Swiss Patent Office. That year, in his spare time, he wrote 4 remarkable scientific papers. The first established the photon as the particle associated with light, overturning many years of understanding light as a purely wave-like phenomenon. He used this new description of light to explain the photoelectric effect. In another paper, he mathematically proved the existence of atoms, something that was still debated at the time, and he actually calculated their size. He introduced his special theory of relativity, which describes how motion can affect the passage of time. And then, with E equals mc squared, he established the fundamental relationship between matter and energy. This explains what makes the sun shine. He was so far ahead of his time that no one even recognized his accomplishment. That is until this man, Max Planck, the greatest theoretical physicist in Europe at the time, and the editor of the journal Annalen der Physik, read the paper Einstein had submitted describing light as consisting of photons. Planck sent an assistant to the patent office to fetch Einstein. This recognition helped get young Albert accepted into the University of Zurich. Max Planck made many important and lasting contributions to the field of physics, but perhaps his greatest discovery was Einstein. This bright young chap is Niels Bohr. He grew up in Copenhagen, Denmark, and received his PhD by age 26. Not too shabby. He studied Einstein's paper proving the existence of atoms, and in 1913 he introduced a conceptual model for the workings of the atom, and it's still the one taught today. A positively charged nucleus is orbited by negatively charged electrons, and these electron orbits have very specific energy levels that are quantized. Bohr's atomic model had enormous impact on atomic physics and chemistry, paving the way for the modern era. He was given a nice position at the University of Copenhagen as a physics professor. Meanwhile, Einstein had been made a member of the Prussian Academy of Sciences and a professor of physics at the University of Berlin. Oh, and he's published a few more papers. In one of them, he answers the age-old question, why is the sky blue? He solved the problem by examining the cumulative effects of light scattering by individual molecules in the atmosphere. Just another day at the office. Well, it's the 1920s and every young boy wants to be Charlie Chaplin. This one wanted to be a scientist. His name is Werner Heisenberg. You may be familiar with his famous uncertainty principle, which sets hard limits on empirical inquiry. In 1925, he introduced a concept known as matrix mechanics in an attempt to explain how energy is absorbed by atoms. He did this by describing atoms not as actual physical objects, but as mathematical matrices that evolve over time. Matrix mechanics was very radical stuff, and it didn't look like traditional physics at all. Niels Bohr accepted Heisenberg's ideas as valid, but most other physicists, including Einstein, thought of them as something of a fad that would fade away once a better theory was found. Heisenberg became a professor himself and started to spread his own ideas. This is Erwin Schrödinger. In 1926, he was teaching physics at the University of Zurich, where Einstein had gotten his PhD. He wrote a paper introducing wave mechanics as an alternative to Heisenberg's matrix mechanics. It was Schrödinger who first claimed that two particles could be entangled and that they would behave as one system, as one thing, mind you, even if they were separated in space. This meant that any interaction with, observation, or measurement of one of the entangled particles would cause an instantaneous effect in the other, even at great distances across space, up to and including infinite distance in space. This is what is known as non-locality. For the majority of physicists, who were, after all, completely invested in a materialist view of the universe, this was truly unacceptable. and simply could not be true, even if all the equations worked. They just needed to put their heads together and figure out what was really going on with this newfangled wave and matrix mechanics. Einstein took particular interest in this problem because it was he who had let the genie out of the bottle with his photon and the quantum theory of light. The 1927 Solvay Conference was held to solve these new problems in defining the properties and behavior of photons and electrons. Talk about some heavy hitters. Of the 29 people pictured here, 17 won Nobel Prizes. Here is Madame Curie, next to her is Max Planck. Here is Einstein, who by this time had overturned Isaac Newton's theory of gravity with his own general theory of relativity, and he was by far the most famous scientist in the world. Here are the young upstarts, Erwin Schrödinger and Werner Heisenberg, the ones who started all this trouble. And here is Niels Bohr, caught in the middle between the youngsters and the older traditionalists led by Einstein. During the conference, Bohr and Einstein began a discussion about the true nature of reality that would become the greatest rivalry in modern science. Bohr's position was that the new quantum theories would prove to be true, that they were the path to the future. But Einstein insisted that this was impossible, that quantum theory simply could not be an accurate description of the universe. Following the conference, Einstein began work on what he called a unified field theory that would eliminate the need for quantum mechanics and fully explain all of the weird phenomena that were being observed and described by the equations of the new quantum theories. Through the 1930s, Einstein continued to reject quantum theory as an inferior model of the universe when compared to materialism. And in 1935, he co-authored a paper with Boris Podolsky and Nathan Rosen to show that quantum theory could not be accurate because of the prediction of instantaneous interaction between quantum bits separated by space. The Einstein-Podolsky-Rosen paper was called "Can Quantum Mechanical Description of Physical Reality Be Considered Complete?" Einstein called the predicted non-local behavior of particles spooky action at a distance, to drive home the ridiculousness of such a prediction. The 1940s were a good time for Einstein. He continued to bask in his rock star celebrity, living in Princeton, New Jersey, teaching at the Institute for Advanced Studies, and collaborating on several important papers. But all the time, he was trying to win the argument with Niels Bohr, working away at his unified field theory to rescue the materialist universe from quantum non-locality. By 1955, Einstein was an elderly man. He had been working on his unified field theory for 28 years to no avail. This was the man who had written 4 groundbreaking scientific papers in a single year. He had explained why the sky is blue, what makes the sun shine, how acceleration through space can slow down time. He overturned Newton's theory of gravity, and many, many more accomplishments. But now he had spent nearly 3 decades trying to salvage materialism and was unable to do so. Albert Einstein passed away on April 18, 1955. Albert Einstein was one of the smartest people who ever lived. In 1 year, he wrote 4 of the most important papers in the history of physics and introduced sweeping changes that ushered in technologies ranging from lasers to the global positioning system. At the end of his life, after spending 28 years searching for a unified field theory built on materialism, Einstein seemed to change his mind about the fundamental nature of the universe.